Standing before a massive steam locomotive, one can't help but feel the weight of history, the hiss of steam, the gleam of brass and iron, the incredible force contained within its mechanical heart. These masterpieces of engineering transformed our world, and their story begins in the workshops and coal mines of 18th-century Britain. The Industrial Revolution sparked a transformation unlike anything humanity had ever seen before. At its core was an invention that would reshape civilization itself, the steam engine. This marvel of human ingenuity would go on to power factories, pump water from mines, drive locomotives across continents, and propel ships across vast oceans. But like many world-changing innovations, the steam engine wasn't created in a single flash of brilliance. It emerged through decades of experimentation, failure, and persistence by numerous inventors who saw possibilities where others saw problems. In the early 1700s, Britain faced a crisis. Its growing industries desperately needed coal, but mining deeper meant dealing with flooding. Horses walking in circles powered primitive pumps, but they couldn't keep up. The mines were drowning, and with them, the future of British industry hung in the balance. Enter Thomas Newcomen, a humble ironmonger and Baptist minister from Devon. In 1712, he introduced what would become known as the atmospheric engine. Picture a giant metal beam, balanced like a seesaw. On one end hung a heavy pump rod extending down into the flooded mine. The other end connected to a large piston inside a cylinder. When steam filled the cylinder and was suddenly cooled by a spray of water, it created a vacuum. The weight of the atmosphere would then push the piston down, lifting the pump rod on the other end. Though inefficient by modern standards, Newcomen's engine was revolutionary, the first practical device to convert heat into mechanical motion. The rhythmic pumping of Newcomen engines soon echoed across Britain's coalfields. Up and down they went, hour after hour, day after day, saving mines from flooding and fueling the nation's growing appetite for coal. But their massive appetite for fuel meant they were practical only where coal was cheap and plentiful. Enter James Watt, a precision instrument maker at the University of Glasgow. In 1764, while repairing a model of a Newcomen engine, Watt made a crucial observation. The repeated heating and cooling of the cylinder wasted enormous amounts of energy. This insight led him to his greatest innovation, the separate condenser. By adding a second cylinder that remained cool, connected to the main cylinder by a pipe with a valve, Watt's engine could maintain its operating temperature, while still creating the necessary vacuum. This seemingly simple change doubled the engine's efficiency, slashing its fuel consumption. But Watt was more than just an inventor, he was also a perfectionist. He spent years refining his design, adding features we still use in engines today. The centrifugal governor automatically regulated speed. The parallel motion mechanism converted the beam's arc into straight-line motion. The sun and planet gear allowed rotary motion output. The partnership between Watt and industrialist Matthew Boulton proved crucial. Boulton's factory in Birmingham became a crucible of innovation, where skilled craftsmen turned Watt's ideas into reality. Their steam engines were marvels of precision engineering, with cylinders bored so smooth and true that Watt claimed you could feel no imperfection with your fingernail. The impact was revolutionary. Where Newcomen's engines had been limited to pumping water from mines, Watt's more efficient designs could power machinery in any location. Factories no longer needed to be built beside rivers for water power. Industries could now grow wherever resources and workers were available. The textile industry was transformed. Steam-powered spinning machines and looms multiplied production capacity exponentially. What once took a skilled weaver days could now be done in hours. The price of cloth plummeted, making fine fabrics accessible to ordinary people for the first time. But the steam engine's influence reached far beyond textiles. Iron foundries used steam-powered bellows to achieve higher temperatures, producing better quality metal in greater quantities. Steam hammers shaped massive pieces of iron and steel. Steam-powered rolling mills produced rails for the growing railway network. The development of high-pressure steam engines opened new possibilities. Rather than relying on atmospheric pressure, these engines used the expansive force of steam itself. Though initially more dangerous, improved materials and safety features made them practical. Their compact size and greater power-to-weight ratio made them ideal for transportation. Richard Trevithick's high-pressure engines powered the first self-propelled vehicles on both road and rail. His 1804 locomotive in Wales hauled 10 tons of iron and 70 passengers along 10 miles of track, the first successful railway journey in history. Though this early attempt didn't lead to immediate widespread adoption, it pointed the way to the future. George Stephenson would later refine these ideas, creating the first practical railway locomotives. His famous rocket, built in 1829, combined several crucial innovations: a multi-tube boiler for better heat transfer, direct coupling between pistons and drive wheels, and the blast pipe, which used exhaust steam to increase the furnace draft. The steam engine's impact extended to agriculture. Steam-powered threshing machines and plows increased food production dramatically. Farms could produce more with less manual labor, freeing workers to seek opportunities in growing industrial cities. In mining, steam engines didn't just pump water, they also hoisted ore and miners from ever deeper shafts, powered ventilation systems, and drove crushing and processing machinery. This increased production of coal and metals fed the growing demands of industry. Steam power transformed transportation. Paddle steamers and later screw-propelled ships could travel against wind and current, making shipping schedules reliable for the first time. Railways connected cities and regions, moving people and goods at unprecedented speeds. The world became smaller, more connected, and more dynamic. The steam engine also drove social change. The need for skilled engineers and mechanics created new career opportunities. Technical education became increasingly important. The regular maintenance requirements of steam engines helped establish the modern concept of preventive maintenance and scheduled repairs. Safety was a constant concern. Boiler explosions were devastating when they occurred. This led to the development of safety valves, pressure gauges, and regular inspection requirements. These practices formed the foundation of modern industrial safety regulations. The steam engine's influence extended to architecture. Factories needed to be designed around their power source. Belt drives and line shafts transferred power from central engines to multiple machines. The iconic factory chimney became a symbol of industrial prosperity. Cities grew rapidly around industrial centers. New urban infrastructure was needed: water supply, sewerage, street lighting. Steam engines powered many of these systems. Municipal waterworks used steam pumps to supply clean water to growing populations. The demand for fuel reshaped landscapes. Coal mining expanded dramatically. Railways were built to transport coal from mines to industrial centers. Forests were cut for railway ties and mining timber. These changes sparked some of the first environmental concerns and conservation efforts. The steam engine also influenced art and literature. Writers like Charles Dickens captured both the wonder and the harsh realities of the steam-powered age. Painters depicted dramatic scenes of railways and steamships. The rhythm of steam engines even influenced music and poetry. The development of steam power required advances in many fields. Metallurgy improved to produce stronger materials for boilers and cylinders. Mathematics and physics evolved to understand and optimize engine performance. New tools and manufacturing techniques were developed to produce precise components. The steam engine drove standardization in manufacturing. Interchangeable parts became crucial for maintenance and repair. Measuring tools became more precise. Technical drawing evolved to communicate complex designs. These developments laid the groundwork for modern mass production. The need to understand and improve steam engines advanced scientific knowledge. The study of heat and energy led to the development of thermodynamics. Scientists like Sadi Carnot analyzed the theoretical limits of heat engines, establishing principles still fundamental to engineering today. Steam engines also influenced business and finance. The high cost of steam engines led to new forms of business organization and financing. The need to coordinate complex railway operations helped develop modern management techniques. Insurance evolved to cover new industrial risks. The spread of steam technology created new patterns of international trade and competition. Nations without coal deposits sought to secure fuel supplies. Technical knowledge became valuable. Engineers and mechanics traveled widely, spreading expertise and innovations. The steam engine's legacy extends far beyond the Industrial Revolution. Its development established patterns of innovation and technical progress that continue today. The systematic approach to improving efficiency, the importance of precise manufacturing, the role of scientific understanding, all these remain crucial in modern engineering. Even as new power sources emerged, steam technology continued to evolve. Steam turbines, developed in the late 19th century, still generate most of the world's electricity. The principles of thermodynamics, first understood through steam engines, guide the design of everything from refrigerators to rocket engines. The story of the steam engine reminds us that transformative innovations often emerge gradually, through the combined efforts of many individuals. It shows how technical progress interweaves with social, economic, and environmental changes. Most importantly, it demonstrates humanity's remarkable ability to solve problems through ingenuity and persistence. Today, as we face new challenges in energy and technology, the steam engine's history offers valuable lessons. The importance of efficiency, the need to balance progress with safety, the role of systematic improvement and scientific understanding, these insights remain relevant as we develop new solutions for the future. Looking at a preserved steam engine today, we see more than just a machine. We see the culmination of countless experiments and improvements, the source of tremendous social and economic changes, and a testament to human creativity and determination. The steam engine didn't just power the Industrial Revolution, it helped create the modern world. As the sun sets on the age of steam, its impact endures. Every time we board a train, visit a power plant, or use electricity, we benefit from the legacy of those 18th century innovators. They showed us that with dedication, ingenuity, and persistence, we can solve seemingly impossible problems and transform the world for the better. The story of the steam engine isn't just about technology, it's about human ambition, creativity, and the power of innovation to reshape civilization. It reminds us that every great advancement begins with a problem to solve and someone willing to tackle it. In that sense, the spirit of innovation that drove the development of the steam engine continues to inspire progress today.